So in this test review, the question 4 is given like this. First, find the slope of the tangent line of the graph here at the point this guy using either this formula or this formula. And M sometimes, yeah, we define it, we call it F prime at A. For now, just accept this, just a definition. Okay, and then find the equation of the tangent line in this part. It means the tangent line at this point. So, observation. What is A in our case here? 0, very good. And what is F of A? Yeah, square root of 2. This is what we're given. We don't know the graph of this, but then let us compute the part A, right? So which formula do you want to use first?
The first one.
Okay. And the first one, the limit. When x approaches A, f of x minus f of A over x minus A. And since we know A is equal to 0, then we replace it, right? What is it here? F of 0 minus x, right? Very good. Now, the f of x, let us write it here so you can look at that easier. Square root of 3x plus 2. So what is f of x? Yes, it becomes limit when x approaches 0 of square root of 3x plus 2. What is f of 0? Very good. The denominator is x minus 0, then it becomes simply x, right? Good job. What should we do? Thank you, Madison. Again, we face a radical sign here, right? And the trick to get rid of this is multiplying with the conjugate of this guy. Very good. The conjugate of this guy is 3x plus 2. Thank you, Kristen. If we multiply with this guy, we must divide it by the same amount, right? Why can't we substitute x is equal to 0 to this? Yes, the denominator cannot be 0, so we cannot substitute it directly. Therefore, we multiply with this guy in order to get rid of the radical sign. Everybody and people on Zoom, is it clear why we do this? Okay. Everyone here, is it clear? Yes. Then how does oh, square root of 2. Good question. Here. Square root of 2 in this case, we are computing f of 0, right? and f of 0, and we're given the function here. F of x is given by this. We substitute the value of 0 here. It will be square root of 3 times 0 plus 2, and then we have square root of 2. Replace it here. We got this. Okay, thank you, Nicholas, Lauren, Joshua. Okay, then let us continue. How does the numerator becomes? It will be the first term square, right? Subtract the second term square, just the formula we applied. And here, the denominator, we just rewrite it. X square root of 3, x plus 2 plus square root of 2. Okay? It will be square of this, the radical sign will disappear, minus 2, right? Denominator will be x times the same things as before. Good job. Can we simplify it here? Yeah, in the numerator, 2 will cancel with 2 here. Remember, in front of this, in front of the parentheses here, there's no sign, or in other words, it is a positive sign. We can get rid of this immediately. Then it becomes 3x plus 2, and then it subtract 2, it disappears. Let me just write it slowly. Good job. Then again, what should we do with this guy? Cancel, right? Imagine. Mm-hmm. Oh, my bad. Yeah, it should be 3 here, right? Thank you, Caitlin. Yeah, sometimes our hand is faster than our mind. Then they cancel. So disappear. It is a constant. Then at 0 is it defined? When we substitute the value of 0 here, the denominator is not 0. Then we're good. Okay. It is also satisfying. This term is positive, then we don't have to care about that. We just simply substitute the value of this here, which will be 3 over, what is it? Yes, square root of 2 plus square root of 2. Therefore, it is 3 over 2 square root of 2. Good. That's it. This is the slope of this.
Can we leave it like that?
Sure. It's even
I don't know if you want us to.
better than radicals, decimal places. It's more accurate. Mathematicians prefer this form instead of writing it in decimal places. Okay. Do you all agree with this? Or do you have any questions?
Three halves. Like with the square root of 2, not add square root of 2, make square root of 4.
No. So this is multiplication. Okay. So just a reminder about this power law. If you don't remember this law, it's easy. Play with simple numbers. So 2 times 2 it becomes, yes, 4. Or we can write it 2 square, right? Definition of power laws. How about 2 times 2 cube will be 4 cube, right? It will also be 4 times 4 times 4, right? Okay. Then 4, we can write it as 2 times 2. 2 times 2. 2 times 2. This is multiplication. So we can simply write it 2 times 2 times 2 times 2 times 2 times 2. We count it, definition of power. Then it becomes 2 to the 6, right? This is one way to get this. Or someone can write it here instead of writing 2 times 2 cube. Can we write it 2 square, then cube? Yes. Then according to this, okay, it's very interesting. This guy is exactly the same as 2 to the 2 times 3. Right. So therefore, in general, if you are given a number 2 to the a, and then you raise to the power b, it will be 2 to the a times b for any number a and b here. Or it is true for 2. It should also be true for another number, for example, x to the a to the b. It will be x to the a times b. This is how you remind yourself about the power laws and things. Just play with simple numbers. Very useful and easy to understand. Okay. Okay. To answer Colin and Lauren. Go back here. So when x is equal to 0, 3 times x plus 2 is a positive number, right? Then it means that it's satisfying the condition of the radical sign here. And the denominator here, this guy, is simply square root of 2. Three over square root of 2 plus square root of 2. If we write it this way slowly, it is this guy. Square root of 2 plus square root of 2 give us 2 square root of 2. One apple plus another apple give us 2 apples. Okay. Is it clear, Lauren and Colin? Okay. Just do it slowly, then you get that. Then the question B, write the equation of the tangent line at the part A. The tangent line, let us continue here. It is y minus f of the point we are computing, we're given here, right? 0.01. It means f of 0 is 1. Is equal to m x minus 0 here. Therefore, y will be, and we're given that f of 0 is 1. And we just found that m is 3 over 2 square root of 2 x minus 0. or x minus 0, let us simply write it as x. Is that okay? Therefore, what is y? Let us call it y1. Very good. That's it. This is the tangent line of this. That is the question B. You can play on decimals, plus these two graphs. Okay, have a good one, and I'll see you tomorrow.